Hello, and thank you for attending CDCon 2021. I'm going to talk to you today about GitOps, specifically about what I like to sometimes call hermetic deployments, or what you might hear as immutable deployments. My name is Tracy Ragan. I am a microservice evangelist. I am the CEO of DeployHub, and I'm also serving on the CDF board as the member representative. So thank you to all of you who voted for me. I've been around a bit. This is not my first open source kind of foundation to work with. I was also on the board of the Eclipse Foundation. I'm a DevOps Institute ambassador, and I am the community director for an open source project called Ortelius. And those of you who know Ortelius will know that our logo is an alien. And I like to talk to people on this subject. If you ever want to chat, there is my LinkedIn address. Please reach out to me. I'll send you an invite for a 15-minute coffee chat, and we can talk about anything from standard lifecycle management to modern day GitOps and building DevOps pipelines. So it's good to always understand things from the beginning. So let's start of where GitOps sort of was born. I first started hearing about infrastructure as code several years back, and that movement was all about creating moving away from imperative scripts to stand up your environments, whether it be in a Kubernetes environment or otherwise, just even a VM experience. The idea being that we're switching from an imperative process to more of a declarative process where you have operations by pull request. This introduced the concept of an operator, and the operator having the intelligence to understand how to act upon a declarative script where you're declaring a future state. And the operator manages that script and determines the future state of your infrastructure. And that's where I began seeing the use of an operator. And the goal was to create this hermetic operations process. It was critical at a certain point in time when we started moving into virtual worlds, where we got away from having a gold disk where we wandered around with a CD in our pocket and updated somebody's laptop. While that may still happen in a virtual world, it doesn't need to. And what needs to happen instead is these things are spinned up in a virtual environment, and IAC made that a lot easier. There were really big benefits to moving away from these imperative processes, namely not relying on a single human to be able to stand up an environment. When you have developers and testers wanting to have these environments, there needed to be an easy way for everybody to stand one up on their own. And infrastructure as code allowed that to happen. So if you were on a development team and you needed to spin up an environment, infrastructure as code allowed you to do that. And it wasn't a huge change in the way ops teams worked. They were already checking in their imperative scripts. That doesn't mean anybody else could use them. It just meant that they were versioning them. But when we moved into a declarative mode and had simple scripts that everybody could understand, we started changing the way in which we saw how we could build out these environments. And adding Git to the process and adding all of the auditing that Git offers was an easy way to start tracking changes and sharing these declarative scripts. Now, in this type of environment, you have an operator that acts upon those scripts. So as soon as you check something into your Git repository, you point your operator to track that, and the operator acts upon that script. So it's locked down, it's hermetic. You can't change it once it's in. And if it is changed, it's being tracked that it was changed. Now, this opened up a huge door for us in terms of how to start managing these environments. And it led us away from being dependent on a particular human to do it. Instead of a human, we were now reliant on an operator. And the idea of triggering an action upon a check-in, we've done for quite some time. Everybody knows that continuous integration was triggered from a check-in for a source code and a merge. So this idea wasn't new to us, and it led to this whole idea of operations by pull request and simplifying the way we stood up these environments in a way that was truly immutable. And if it was changed, it was tracked. So then somewhere along the road, somebody said, well, if we can do this with day one events, and when I say day one, I mean standing up the infrastructure, why not day two events, meaning updating applications inside inside that environment? And why can't hermetic application deployments be a reality? So that IAC model started being applied to deploying what I call containerized application. Now, a containerized application is still a monolithic. You're putting your entire application into a container, including anything you need to run that, and you push that out. So it was a small addition to this infrastructure as code experience. And we can give Weaveworks some credit for taking the charge on this one. They are known for now as the GitOps company, or the first company to really start talking about GitOps. So we should acknowledge Weaveworks for their brilliance in saying, hey, if we can do this in day one, why not always be able to do day two events? And a shameless plug. We had a GitOps Summit, a day zero event. If you missed it, those videos recordings should be posted out there for you after this. I'm sure there will be an announcement made where you can see this stuff online and on demand. I highly recommend you watch our keynote. It includes Cornelia Davis, Dan Lawrence, and Dan Garfield, as well as myself, talking about GitOps and how it got started. Cornelia is brilliant in explaining these things. Anything she does, I highly recommend watching. So let's talk about GitOps and application deployments, how Weaveworks got us there and why it's hermetic. Let's just talk about the architecture. In a GitOps environment, in your cluster, we're just going to refer to it in this model, and people will tell you you can use GitOps in many ways, and we don't have enough time to talk about all the ways you could probably apply it, so we're going to use this common model. In this environment, you have a GitOps operator that's running in your cluster. That GitOps operator looks at two things. It looks at an environment repo in Git or whatever repository system you're using, and it looks at your registry. So where you're registering your container images and where your deployment YAML file exists. Now, in your repository side, and in this example, I'm using Git, you're going to have two different repositories, and this is how most setups are. You have what we call your code repository, which you're used to. You're checking in and checking out code out of your code repository. But you're also going to have a second repository, and that repository is your environment repository. That is where your operation teams are going to start managing these deployment files, and that's where you declare your desired state. So as a developer, you're going to check in a deployment YAML file for your application, and you're also going to register your container image. The GitOps operator monitors the repository. If a repository is updated, the GitOps operator acknowledges that it's been updated and then updates the cluster to reflect the state that you desire. And this is done for your development, your testing, and your production clusters, or however many clusters you have out there. So you define at the GitOps operator what repositories you're going to be monitoring, whether it be your container image repository or where your YAML file is being stored. Now, the beauty of this also means that if somebody manually tweaks the cluster, the GitOps operator is going to fix that for you, because it's going to go, oh, I'm out of state, so I'm going to go back and look at my desired state and correct it. So that is why it becomes a hermetic or immutable, because you're always going back to your GitOps, your Git repository, and your GitOps operator is always checking against it and making sure that the desired state, as defined in your YAML file, stored in the Git repo, is what the cluster looks like. Perfect, brilliant. So let's go through that again, because I went through it. Let's go through it in steps. So as a developer, you make an update to the code and you commit those changes to Git. You create a new container image and registered, which then creates a new SHA, or in particular, a new tag. That tag makes that particular container unique, and that tag is what ends up in that YAML file. So the developer updates the YAML file with a new tag and then commits it back to the Git environment. These are the simple things. There may be environment variables that have to be updated too. that just depends on what that update is needing. So there may be some environment variable changes that occur as well. And then the GitOps operator sees the new commit, updates the cluster with a new container, and we are done. The solution is hermetic. A manual tweak to the cluster is overlaid by the operator as soon as it happens. So if you want to know what's happening in your cluster, you go to Git for that information. So I talked a lot about scaling GitOps and can it scale. From a purely operator cluster kind of configuration, it scales marvelously. Each cluster can have its own GitOps operator, so it's not overloaded in any way. It can scale to hundreds and literally thousands of clusters without any real problem. So one of the benefits on the purely technical architectural side of the house, it scales very, very well. So you're not thinking about trying to create a distributed deployment model where you're building out all these agents. You just got basically an agent running in your each cluster that monitors those repos. Simple. But there is a human side to everything. And we have to question anytime we make changes like this. And this really speaks to the continuous deployment part of the continuous delivery pipeline. You have continuous build, you have continuous test, and you have continuous deploy. And you have to deploy to dev, test, and prod, because you can't test without something deployed. You can't even do a unit test without deploying something. So deployment is a key part of our DevOps pipeline. I often see presentations, and they always show delivery is the last step. You have build, test, and then deliver. Well, deployment is a part of all of those steps, and the GitOps process fits into all of those different stages. So we have pipeline considerations, and we have the human consideration. So let's just talk about the pipeline. Why am I saying that? Let's think about how this is going to scale. In the example I gave you, we had a containerized application that had one big YAML file that defined its deployment state, what we want the GitOps operator to read and to maintain for us. When we start building it out into a lifecycle model, we're going to start creating additional branches. We have dev, test, and prod, for example. Developers would be updating the development branch, production would be maintaining production, and test would be updating the test branch. Now, they're different for many reasons. Obviously, you're running different versions in all of these, so you have different SHA tags in that YAML file. You also have different variables, production variables. How production is set up to execute that particular container may look different than development. So there's differences in them, subtle, small differences. Now, in some cases, you may just have one trunk with multiple YAML files that the operator interrogates. Regardless, you're going to have more than one YAML file that you're trying to manage. You can't get away from it. That's just the way it's going. That's just the way it is, because that's the way we develop. We don't develop in production. We don't. So you're going to have separate ones. And then let's talk about GitOps and microservices. In our first example, we talked about a single application container. Everything was stored in that one big container, and more than likely we had one YAML file to take that container across the dev, test, and prod states. In a microservice architecture, we are breaking up, and breaking up is very hard to do. And you have lots of moving pieces. So when we start stretching our arms out and giving a microservice architecture a big hug, it disrupts many parts of our DevOps pipeline. It disrupts pretty much everything, and it disrupts GitOps as well. I often talk about the disruption in the pipeline, but when you start really biting down on this new microservice architecture, anybody who's worked in a kind of a Jenkins pipeline experience or any CD pipeline experience, you're going to start understanding that things look a little different. So it's going to complicate not just our GitOps model, but it complicates a lot of pieces. But in particular, there are challenges that you will find with the GitOps model in the number of YAML files you will eventually need to monitor. Because in a microservice architecture, you're going to start breaking up that application YAML file, and instead that's going to contain a lot less. It's going to make less changes. You're going to have more containers to manage. So let's just think about some ways that people are setting up their sort of their microservice architecture. And I know that these are very simple images here, but they're intended for conversation. So there are some things that I know that are missing out of here, but we're not going to go into those, dig down into the details of how you set up a Kubernetes cluster or namespaces. So just bear with me on these kinds of concepts. So let's say, for example, we are running a store that we're running a company that manages different stores. We have a candy store and we have a hipster store. The candy store and hipster store share services. They share the shipping, payment, and the cart service, for example, but they have their own front end. The application team, more than likely, would be the team that would be managing the YAML file and the deployment of the front end, while potentially other teams could be pushing out these shared services. Somebody who's writing microservices for shipping functions, payment functions, cart service functions, may be pushing those out independently. So now we've broken up this this monolithic, and we're starting to share services as a company, which is what a microservice architecture should do. Which means that we're going to have more YAML files. Instead of just having one to manage the entire candy store, we're going to have ones that manage individual pieces of it. Now, it's true you could manage the candy store in this configuration with one big YAML file that addressed all of them, but that may hinder your experience with microservices a bit, because what you want to be able to do is not, as an application team, worry about the shipping, payment, and card service, but let somebody else worry about that for you. Now, there's other ways to build your environments, your Kubernetes environments, and this is more of a service, a shared service-oriented architecture, whereby the cart service, shipping, and payment service are in their own namespaces, and they're communicating with the candy store and the hipster store. The GitOps operator would know about all of those, and it would be able to update all of those at any point in time. There's going to be more YAML files. Now, I'm showing you just for one specific environment, and you can see that we start building out more and more YAML files to manage this. While this is a bad good thing, I guess you could say, this is something that we can fix. We can start fixing the way that we manage these different YAML files from the human side. But keep in mind, as we build these environments out, these YAML files will get bigger and bigger. You'll have more and more, because you're going to have ones for development, ones for test, and ones for production. And some of our customers have, we have customers with 15, 20 test environments. So if those have tweaks between them, potentially you're going to have different YAML files for those. So it can get really big. We can get a lot of YAML files. So lots of deployment files to manage manually is the point here. So even though we consider GitOps a human kind of, or an automated process, you still have a human doing the push to Git. They're still making the updates to the SHA, or to the YAML file that represents the tag that came from the SHA. They're still having to do merges if there's merging requirements, because two people updated the same thing, just like in code. And as we expand into microservices and we add it to the CI/CD pipeline, we just have more things to think about. The number of files can become a little bit onerous. So while we want to continue with this incredible hermetic solution, really the heart of what GitOps is all about and what infrastructure as code taught us, we still need a way to automate. We still want the CI/CD pipeline to be automated. We don't want to wait for someone to do create a pull request or do a merge or do an approval. These things need to be part of the automation. And that's the front side of GitOps. It's not GitOps itself, but it's still a key part, because we're talking about moving from a CI/CD pipeline that we didn't really think about having to stop this is automated. Maybe you had a gated approval to get to production, but it was just an approval. Now we're talking about stopping the process and doing something outside of the CI/CD pipeline and checking in updating a YAML file with the correct tag and pushing it back, and then doing a merge, and then doing an approval. So there are steps that really can disrupt our automation that we work so hard for in CI/CD that we should be thinking about fixing. And how do we do that? First, we want to remove those manual steps from the GitOps process. In particular, automate the creation of YAML files and automate the Git steps, the check-in, merge, and approve steps. So this is a topic that we have selected in the Ortelius project to really address, automating the front end of GitOps. And just so you know, Ortelius is a incubating project with the CD Foundation. It became an incubating project back in December. We have a fabulous team of contributors. We have a little over 100 people who are part of the group, and I'd say we have about 30 really committed developers who are starting to really bite down on this particular problem and address it. Ortelius is a microservice management platform. It versions and tracks microservices along with their blast radius and their inventory across the clusters. It really provides a proactive view of microservice architecture and as it changes over time. As a result, we have a lot of the data that's needed to generate the information in a YAML file. And in many ways, we are already doing that, and we're tracking things across the cluster. So you're able to see it in a way that integrates in with Git, but gives you some visibility and automation that I believe is critical to really push the GitOps technology further. So let's just think about what Ortelius does today. So today what Ortelius does is Ortelius gets woken up at the point in time that a new service has been registered. At that point in time, it gets triggered, it captures the SHA and the tag, and for each version of a image that has been registered, we do it for every single time a new image is registered. We grab that because it's a release candidate, and if it's a release candidate, it's probably going to go. Once we grab that information, we then can be triggered by an external solution to say, okay, we're going to go ahead and do the update. We want the update to occur. Ortelius tracks what is doing that. So for example, if you have a Helm chart, we actually generate an overrides file based on the environment which it's going to, because we not only hoard data like the SHA, but we also hoard data like environment variables and key value pairs based on the environments being deployed to. So we track that as well. And when somebody like a Helm or Spinnaker tells us to go out and do it, we make sure we provide that overrides file so that it is ready to be deployed, and then we listen on the backside to make sure that it went, and we then track what was deployed across all your clusters. So that's how we track what we call the blast radius. We know if a single container has been updated, we know the applications that are consuming it, and we know where it's been deployed, which means we know which application versions have now become new because we know what container version is new. It's a whole new world in configuration management. So Ortelius is a data hoarder. We like data, and we pull that data into a single dashboard to track this information. We track the metadata, and we put that in a central catalog of microservice configuration management. It is our core data store. And as I said, we like to separate the data from the definition, and we store the key value pairs so that we can begin generating these kinds of files on the fly. And we store all the SHA information. And this is the data that we will use to automate what we're calling the front end of GitOps. And the goal is to continue to keep it as hermetic as possible. And the more we take a human out of it, the more hermetic it becomes. So there's two generic ways that we're looking at adding this to the Ortelius roadmap, and a group of brilliant minds out of Australia is specifically working on this project for us. the two ways would be, one would be a Helm GitOps operator, and then you have one that's uses a Kubernetes deployment YAML. And either way, Ortelius would generate the values for the YAML file for the correct environment repository. It would then check that new YAML file into the environment repository, and after check-in, it would do all the other manual steps. We would automate that, even up to the approval process if that is allowed, and that would have to be opened up to Ortelius on the Git side. The Kubernetes YAML file would be exactly the same. It would just look differently, a little bit of different structure. And again, after check-in, we would issue all the pull requests to stage the change and do the automated approval and merge if that was allowed. And we're hoping that it can be, because that's the key to making sure we're automating all of these parts and pieces. But if you're still looking for that gated approval, then then the approval is still there and you can still do that. So what would it look like once we do the integration? What we're hoping to have really begin working on in the late summer and fall. We would still have that, we would still be woken up just the same way as we are. We would be triggered by a new image being registered to a container registry. But instead of actually doing a push to a deployment solution, we would call what we call a custom action that would generate the YAML file based on it being a Helm or a Kubernetes deployment file. And that depends on the operator as well. And we would go ahead and push it out to Git so that could trigger the operations by pull request. We would then track that we actually delivered it to the Git repository, so we know what environment we actually delivered it to. So the data pretty much is the same. You're still using your Git and GitOps to manage those hermetic deployments. And we're adding another level of security by generating these pieces. And you can always go and see exactly what SHA or what tag was used, because we're going to track all of those pieces separated from the YAML file itself in the database, so you can see it and report on it. So thank you very much for taking the time to hear my thoughts on GitOps and the front end of GitOps and how we need to maintain that hermetic deployment process. It is brilliant. We need to be able to, in the future, have a continuous delivery pipeline that really deploys in a repeatable way between dev, test, and prod. And we've been working on this problem for quite some time now. Not everybody actually uses their CD pipeline to deploy all the way to production. Most are doing dev and test. We are now at a point in time that we need to start thinking about really automating these pieces, because as you move into microservices, there's a lot of files to be pushing. It's not about, we're doing really great indoor metrics because we're deploying once a day. You should be deploying all day long. So those metrics sort of change too. Microservices, they disrupt everything. You can follow me on Twitter at Tracy Ragan, and find me on LinkedIn at Tracy-Ragan-OMS if you want to chat. And hey, if this is something that sounds exciting to you, join the community. Check us out on GitHub and follow us on LinkedIn and Twitter. Thank you, and enjoy the rest of the show, and hopefully I'll get some questions. Hey, any questions out there? Happy to answer them. Yeah, they are pretty out there concepts, right? Configuration management's always been a challenge for people, and microservices just breaks the puzzle up into tiny pieces and makes CM even more important. Okay, if there's no questions, I will see you guys hopefully in the DeployHub booth. Come say hello. And thank you, Brian. Thank you, Brian, for being out there for us. Oh, yeah, you have one. Okay, we're going to get closed down in a few seconds. Thank you, Juan. Oh, Tiffany, thank you. Is my experience in distributed monoliths common? Not sure what that means, but I have been in the business for quite some time. A distributed monolith, I'm not sure what you're referring to there, if it's being distributed to multiple platforms, or if you're talking about breaking up a distributed system and starting to implement a domain-driven design. Things that have to be deployed at the same time. We call that a release. And yes, a release train is an important part of monolithic deployments. I'm not sure how that's going to look in a microservices world, but I believe that we do have some customers who are asking how to coordinate multiple things changing. There is an interesting CNCF. Perfect, Brian. Do elaborate on Discord. But on that topic, there's a CNCF working group through the application delivery SIG called Application Enablement that talks about coordinating application releases, database releases, and infrastructure releases, which we have termed cooperative delivery. If that is something that's an interest to you, consider looking at the app delivery SIG at the CNCF. Okay, thanks all. We are going to get, so we will see you later in the I guess the happy hour. Thanks. Bye-bye.